From today onward, I will spend a lifetime telling the internet about the cosmos. Even if, for now, only a few signals are listening, and if one day this channel gathers millions of people who still look up at the stars with wonder, then that will become a cosmic romance created by both you and me. When I was younger, I imagined the first sign of alien life would be obvious. Maybe a radio message. Maybe city lights on the night side of a distant planet. Maybe some unmistakable signal from another intelligence saying, "We are here." But the older I got, and the more I learned about astronomy, the stranger that dream became. Because the first sign of life beyond Earth may not arrive as a message. It may arrive as a tiny dip in starlight, a faint chemical fingerprint, a signal so small that scientists argue for years over whether it is real. Tonight, we explore a world called K218b and why the first possible sign of alien life may turn out to be something much more complicated. K218b is not a second Earth. That is the first thing we have to understand. It is about 8.6 times as massive as Earth, and it orbits a cool red dwarf star roughly 120 light-years away. It sits in the star's habitable zone, which means the temperature could allow liquid water under the right conditions. But this world belongs to a class of planets we do not even have in our own solar system. A sub-Neptune, larger than Earth, smaller than Neptune, possibly wrapped in a thick hydrogen-rich atmosphere, maybe even an ocean world. Scientists sometimes call this kind of possible planet a Haitian world, a planet with hydrogen in the atmosphere and a global ocean below. That sounds beautiful, almost too beautiful. A warm ocean under alien skies, a thick atmosphere, chemistry, possibility. When NASA's James Webb Space Telescope studied K218b, it detected methane and carbon dioxide in the planet's atmosphere. That alone was exciting, because studying the atmosphere of a planet more than 100 light-years away is already one of the most impressive things humans have ever done. We are not flying there. We are not taking a photograph of its ocean. We are watching the planet pass in front of its star. When that happens, a tiny fraction of starlight filters through the planet's atmosphere before reaching Webb. Different molecules absorb different colors of light. So if you split that light apart, you can look for missing pieces. Those missing pieces become clues: methane, carbon dioxide, water vapor, maybe something stranger. This is called transmission spectroscopy, and it is one of the main ways we study worlds we may never visit. But here is the problem. The signal is incredibly small. The star is bright. The planet is faint. The atmosphere is thin compared to the size of the system. And the data has to be cleaned, processed, modeled, and interpreted. That means the first possible sign of life may not look like a discovery. It may look like a disagreement. And that is exactly what happened. One of the most interesting molecules discussed around K218b is dimethyl sulfide, or DMS. On Earth, most DMS in the atmosphere is produced by living organisms, especially marine microorganisms like phytoplankton. So when scientists saw a possible hint of DMS in the atmosphere of K218b, people paid attention. Because if a distant ocean world had a gas that on Earth is strongly connected to life, that would be extraordinary. Later, researchers using Webb data reported possible evidence for DMS, or a related molecule called DMDS. The headlines were impossible to ignore. Possible signs of life. Strongest hint yet. Alien biosignature. And I understand why people got excited. I did too. Because somewhere deep down, I think many of us want the universe to answer. We want one molecule to be enough. We want one signal to finally break the silence. But science is colder than hope. A possible biosignature is not proof of life. A biosignature is not magic. It is a clue, and clues can lie. The first reason is that chemistry is creative. A molecule that is mostly produced by life on Earth may not require life on another world. K218b is not Earth. Its atmosphere may be hydrogen-rich. Its temperature, pressure, radiation, clouds, and chemistry could be completely different from anything familiar to us. In that kind of environment, non-living chemical reactions might produce molecules that look biological from far away. That is called a false positive. And false positives are one of the biggest problems in the search for life. Oxygen can be a biosignature, but oxygen can also build up without biology under certain planetary conditions. Methane can be linked to life, but methane can also come from geology. Even water does not mean life. It only means one condition may be present. The universe does not label its planets for us. It gives us chemistry. Then we have to decide what the chemistry means. The second problem is confidence. The reported DMS and DMDS signal around K218b was exciting, but not final. The researchers themselves said more observations are needed. Other scientists have looked again at the same planet and reached more cautious conclusions. A later NASA-led analysis found no conclusive evidence for DMS, while still showing that K218b is a fascinating and complex world. This is not embarrassing. This is how science works. A claim is made, other teams test it, models improve, data is reanalyzed, excitement gets filtered through skepticism. And slowly, if a signal survives every attempt to destroy it, we begin to trust it. That is what makes the search for alien life so difficult. We are not only searching for life, we are searching for evidence strong enough to survive human doubt. And maybe that is exactly how it should be, because the first real discovery of life beyond Earth would be one of the most important moments in human history. It would change science, religion, philosophy, our understanding of Earth, our understanding of ourselves. So the standard has to be high. A single molecule is not enough. A strange spectrum is not enough. A dramatic headline is not enough. We need repeated observations, multiple instruments, independent teams, a full atmospheric context, a way to rule out non-biological chemistry. And even then, the answer may not be simple. Imagine the first confirmed alien life is not a civilization, not a signal, not a face looking back at us, but microbes in a distant ocean we can never touch, detected only through chemistry. No images, no bodies, no direct sample, just a pattern in light. Would that feel satisfying? Or would it feel almost cruel? A universe finally whispering back, but in a language so quiet that only statistics can hear it. This is what K218b teaches us. Not that we have found life. We have not. Not that the signal is meaningless. It is not. But that the search for life is entering a strange new era. An era where the question is no longer just, are there planets out there? We know there are. The question is no longer just, can some planets have atmospheres? Webb is already showing us they can. The question now is, can we tell the difference between life and chemistry pretending to be life? That question is much harder, and maybe much more important. When I think about K218b, I do not imagine an alien ocean filled with life right away. I imagine scientists on Earth staring at a spectrum, arguing over tiny features, asking whether a small bump in the data is a molecule, noise, clouds, instrument behavior, or something nobody has modeled yet. It is less cinematic than First Contact, but in a way, it is more human. Because this is how we really approach the unknown, not with certainty, but with careful doubt. Maybe K218b is alive. Maybe it is just chemistry. Maybe it is teaching us that the universe can look biological without being biological. Or maybe it is the first faint edge of the greatest discovery we will ever make. We do not know yet. And that uncertainty is the point. So here is the question I want to leave with you. If scientists found a weak but exciting signal that could mean alien life, would you want them to announce it early? Or wait until the evidence is almost impossible to dispute? Some people believe humanity deserves to hear every possible hint. Others believe premature excitement can damage science and turn discovery into entertainment. I want to know which side you are on, because the first alien life signal may not be a message from the stars. It may be a question. And for a long time, we may not know whether the universe is answering us or only echoing our own hope back into the dark.